Hi guys, this is the lesson video for 3C, and on this video I'm going to show you example 2 and example 3, okay? So on our notes, page 7 of our notes for 3C, you can see that example number 2 is 8 square roots of 12 plus 6 square roots of 27 minus 2 square roots of 15, okay? And what we learned when we were looking at 3C was that we can add and subtract radical terms if the number inside of the radicals is the same. But when we're looking at this expression, we don't see any numbers inside the radicals that match. And so instead, we're going to need to simplify each radical term to see if we have a like term buried inside. And when we do this, the way we're going to do this is we're going to separate or simplify each of these three terms individually. And when we do that, sometimes it's useful to just draw a line between the terms so that it's easier to tell what we're working on. So this positive 8 root 12 will have its own little space, and then we'll have a space for our middle term, and then finally this last term. Now these are just lines that are helping us organize our work, okay? So we're gonna go ahead and use our prime factors and our factor trees to see if we can simplify 8 square roots of 12. When we start simplifying it, we got a factor tree that looks like this. Now as we get into examples where we have multiple terms that we're going to simplify, I'm going to show you a shortcut. So instead of circling our primes, I'm going to leave it like this. So long as it's a prime number, I don't need to keep factoring, okay? And that way, instead of writing everything back in the radical, I can simply circle any pairs of primes in our factor tree. And for every set of 2, because our index is 2, or it's an invisible 2 on each of our square roots, right? Those 2's will bust out and we'll have 2 times 8. Yeah. And then our 3 got left inside, okay? And so we'll want to multiply that 2 and the 8, and so our 8 root 12 simplifies to 16 root 3, okay? And I'm going to actually write that in a different color so it's a little more obvious what our simplified term is, okay? Now let's try to simplify 6 square root 27. Now 2 does not go in evenly, so we need to try our next prime, which is 3. And that will factor to 3 times 3 times 3. And so since we've got a match there, we can break that out. And we'll have plus 6. That's really important to bring down our sign. So plus 6 times this 3, 2 on the inside breaks out 1 on the outside. This 3 did not have a buddy, so it stays behind, okay? So I'm going to write that a little bit smaller. And when we multiply the positive 6 and the 3, we'll get plus 18 root 3 when we simplify that second term. All right, so let's try this last one. This will, our 15, our square root 15, factors to 3 and 5. We don't have a match there. That means we can't simplify that term anymore. So that term will just bring down as minus 2 root 15. And now we're going to look to see what our problem looks like here. And we can see that since we have a root 3 here and a root 3 for our second term as well, we can combine our first and second terms. And when we do that, that radical 3 stays the same when we're adding and subtracting, but we'll add those numbers on the outside. So when we add those terms, we'll get 34, that's adding up the numbers on the outside, roots of 3, minus 2, roots of 15. And that's our answer for example number 2, okay? So remember, we're going to try to simplify each term, and then once we do, we'll combine any terms that are like terms. And when we're talking about like terms for radicals, we need to have radicals that have the same index, right? And the same number on the inside. So really important that we get clear, like terms for radicals means our index is the same. That means if you don't see a number, okay, our index is the same. It's an invisible 2. And the number inside has to be the same. And then if we have those two, we can combine those terms, all right? All right, let's go ahead and look at example number 3. All right, for example number 3, on 3C, we have 4 square roots of 50 minus 3 square roots of 125 plus 2 square roots of 20. And again, we want to see if we can combine any of these terms. But the numbers inside our radicals are all different. So we're going to simplify our radicals to see if we have any like terms kind of buried underneath, okay? Now remember, all of our terms are separated by an add or a subtract to the left of the term. And that way, sometimes if we make a nice little line, we can separate our work when we're simplifying these radicals, okay? Now here I can go 2 and 25, and 25 factors to 5 and 5. So my prime factors for the square root of 50 are 2 and 5 and 5. And since I have a match of 5, those two can bust out. 2 on the inside, 1 on the outside. Now the 4 will multiply that 5. And since the 2 didn't have a match, it stays behind, inside the radical. All right, we'll multiply the 4 times the 5, and we'll get 20 square roots of 2, all right, for our simplified first term. Now let's go ahead and do that next term. So for this next term, if we were to divide by 2, we'd get a decimal. We don't want that, okay? So what if we divided by 3, okay? That won't go in evenly either. So instead we're gonna go 5, okay? So when we simplify 125 to its primes, okay, we get 5 times 5 times 5. And since we've got exact match there, we can bust those out. So 2 on the inside, 1 on the outside. We've got to bring down our -3 here. It'll multiply times that 5 that busted out. This 5 didn't have a match, so it's got to stay inside. So when we multiply our -3 times our +5, we're going to get -15 roots of 5. All right, let's do our last term real quick. So for 20, we can divide by 2, right? That'll give us, when we go down to our primes, we'll have 2 times 2 times 5. And we need a match of 2, which we have. 2 on the inside will bust out and give us 1 on the outside. Our plus 2 will now multiply the 2 that busted out, and our 5 didn't have a match, so it stays behind in the radical. If everything comes out of the radical, our radical goes away. But when we have anybody left, we've got to keep that radical. So when we multiply our plus 2 and our 2, we'll get plus 4 roots of 5. And now we're going to look at our new terms. These are the terms after we simplify them. We can see that we can combine our root 5 terms. We can't combine anything with our root 2 terms, so it's going to stay the way it is. So when we combine our like terms, we'll get 20 roots of 2. That's this term. Our negative 15 roots of 5 plus 4 roots of 5 will combine to negative 11 roots of 5. Okay? And that's our answer for example number 3 on part 2C. All right? So for more examples, look for another 3C video. But this video showed you examples 2 and 3 on part 3C. All right, thanks for watching, guys.